Hey guys, hope you all doing great. So today we're gonna discuss about the properties of process synchronization. So let's get in with our intro first, so that we know like we're gonna discuss about. So as we all know, like during concurrent execution of processes need to enter the critical section at times for execution. It might so happens that because of the execution of multiple processes at once, the value stored in the critical section becomes inconsistent. In other words, the value depends on the sequence of execution of instructions, also known as a race condition. The primary task of process synchronization is to get rid of race condition while executing the critical section. So let's get with our first property of process synchronization, also known as mutex or mutual exclusion. So mutual exclusion is a property of process synchronization, as we discussed before, which helps to prevent simultaneous access to a shared resource. So we can say that mutex comes into picture when two threads works on the same data at same time. Just so you guys know, only one thread's work owns mutex at a time. So when a thread gets resource, it locks the mutex from other threads to prevent concurrent access of the resources. So it acts as a lock and is the most basic synchronization tool. When a thread tries to acquire a mutex, it gains a mutex, but if it's not available, the thread goes to sleep condition. So let's get away with our second property. It's known as progress. So it's a property of process synchronization which is used when no one is in the critical section and someone wants to get in. We can also interpret it as like if no process is executing in its critical section and some processes wish to like enter their critical section, then only those processes that are executing in their retainer section can participate in deciding which will enter in the critical section next. And this selection cannot be postponed indefinitely. So the purpose of this condition is to make sure that either some process is currently in the critical section and doing some work, or if there was at least one process that wants to enter the critical section, it will and then do some work. And now let's see the third property. It's known as the bounded waiting. So after a process make a request for getting into its critical section, there's a limit for how many other processes can get into their critical section before the process request is granted. So after the limit is reached, some system must grant the process permission to get into its critical section. The purpose of this condition is to like make sure that every process get the chance to actually enter the critical section so that no process starts forever. So there must exist a bound on the number of times that other processes are allowed to enter their critical sections after a process has been made a request to enter its critical section and before that request is granted. So I think so like that's it for this video. I hope you guys are doing great.